Alright, so here is the second video on solving differential equations using separation of variables. You can check out my first video. I'm just basically what I'm doing is just one problem per video. So when we're solving differential equation using separation of variables, we want to be able to write the differential equation in one of these two forms here. Okay, and like I mentioned in the first video, we want to be able to get all the x terms with the dx and the y terms with the dy. Okay, all the x's with the dx and all the y's with the dy. Alright, so let's check out the second example. I have dy dx is equal to 6x squared over 2y plus cosine y. Now, to solve this, I'm going to use separation of variables. So I want to be able to get all the y terms with the dy and all the x terms with the dx. So you can see here how I have this 2y plus cosine y in the denominator. Well, what am I going to have to do to solve this? Well, let's see. Let me see if I can't move this over a little bit, give me a little more room on the left hand side. Alright, so to get the y terms with the dy, what I'm going to need to do is multiply both sides by 2y plus cosine y. 2y plus cosine y. Okay. And you can see that's going to cancel over here. So I'm left with 2y plus cosine y times dy dx equals 6x squared. And then I need to get this dx with the x, so I'm going to multiply both sides by dx. And so that's going to give me 2y plus cosine y times dy equals 6x squared dx. Alright, so now you can see everything, all the y terms are with the dy and all the x terms are with the dx. So now to solve this, I'm just going to integrate both sides. Okay, and remember, and keep in mind, this left hand side I'm integrating with respect to y, and over here I'm integrating with respect to x. Okay, alright, so when I integrate this, this is going to give me y squared plus sine y. Okay, and remember, if you watched the first video, remember how we talked about the plus c, the constant term, equals, and then this is going to be 2x cubed plus another constant term, and in the first video we called it d. Okay, and I'll go over this again. Alright, so remember, if we subtract c to both sides, okay, the c's are going to go out, and that's going to give me d minus c. I have an arbitrary constant minus another arbitrary constant, and that's just going to give me another arbitrary constant. So I don't need to add the c to this side. Okay, I don't need to add the constant term over here and the constant term over here. I just need to add it to one side. So I'm going to add it to the right hand side, so I get 2x cubed plus, and I'm going to call it c1. If you remember in the first video, sometimes we may need to rewrite the constant term. Okay, so we'll call it c1. Alright, So now in this problem, well, if you watch the first video, we have to solve for y, but we can't really solve for y here, can we? Well, what we're going to do when we can't solve for y, I mean, you could leave it like this, but a lot of times what we want to do is we want to solve it for the constant term. Okay, so let's subtract the 2x cubed to both sides, and so that's going to give me y squared plus sine y minus 2x cubed equals c1. Okay, and so you can see that I have an implicit function over here. Alright, and there's nothing I need to do with the constant, and I've just got c1 equals this. So what I'm going to do is I'm going to take off this 1 here and just call that my constant term c, and so I get c equals y squared plus sine y minus 2x cubed equals c, and this would be my answer. Okay, so I hope this video's helped. Check out my other videos if you like this one. Alright, I'm going to probably do maybe 1 or 2 more separation of solving differential equations using separation of variables. Alright, thanks.